Hi, welcome to Cracking MBA. Today we are going to talk about reminders, which is one of the concepts in numbers. We shall discuss about reminders and look at the different types of methods to solve the questions in reminders. So remainder is the number which if subtracted from a number makes it perfectly divisible by the divisor. Okay, so let's take a simple example. Let us see what is the remainder when we divide 29 by 3. Okay, so we know that 29 is not a perfect multiple of 3. So we need to subtract something from 29 so that it is a multiple of 3. So clearly we know that since 3 is a small number, we know the multiples of 3. So we know that 27 is a multiple of 3 and that is nearest to 29, sorry. And the remainder is 2. Why is the remainder 2? Because if I subtract 2 from 29, we will get 27, which is a perfect multiple of 3. Okay. So another way of looking at it is to identify the maximum multiple of the divisor, which is less than the number, and finding the difference between the number and the multiple. Okay. Now let us look at an example to understand this. So in our case, we said, what is the remainder of dividing 29 by 3? Okay. So we see that 27 is the nearest multiple of 3, which is less than 29. Okay. So all we need to do is find the difference between 29 and the nearest multiple, which is 27. So the remainder is 2. Okay. So for a majority of you, identifying remainders should not be a problem because this is what you have been doing all through high school. Let's look at the focus of this particular video would be primarily to understand the remainders for some advanced type of questions. Okay, but nevertheless we'll still cover some basics for the benefit of all. So now let's calculate some remainders, just for practice. So the remainder of dividing 31 by 7 is 3, as 28 is the maximum multiple of 7, which is less than 31. Similarly, the remainder of dividing 3841 by 8 is 1. So clearly if you divide 3841 by 8, you will get 8 4s are 32. That leaves a remainder of 6, that is 64. 8 8s are 64, then 8 zeros are 0. So that reveals the remainder of 1. So the multiple is 480 and the remainder is 1. Similarly, the remainder of dividing 7788 by 7 is 4. Why? Because 7, if you divide 7788 by 7, you'll get 1, 1, 1. That will remain, and again 18, 7 2s are 14, that leaves a remainder of 4. Okay. So I hope it is clear to you how we calculate the remainders just by direct division. Okay. Let us now see how we can write it in a form of an equation. So if a number n is divided by a divisor d with a quotient of q and the remainder is r, then the number can be written in the format of n is equal to divisor into quotient plus remainder. Okay, so n is equal to dq plus r. This is how we can write any number. Okay, if we know what divisor, quotient and remainder is, then we can write it in this particular format. Now, if r is equal to 0, which means the remainder is 0, then n is a perfect multiple of q. Okay, so let's see this over here, how this equation is written. So going back through the examples that we've seen in the previous slide, we can see that the remainder of dividing 31 by 7 is 3. So we can write it as 31 is equal to divisor of 7 into quotient of 4 plus 3. Okay, n is equal to dq plus r. Similarly, 3841 can be written as 8 into 480 plus 1. Similarly, 7788 can be written as 7 into 1112 plus 4. Okay, so what this means is that if I remove 4 from 7788, it will be a perfect multiple of 7. Okay, so that is what is the concept of a remainder. Now there are different types of approaches to determine the remainder. One is the direct division method, which we have been seeing all the while. Next is the pattern method, and third one is remainder theorem method. So let's look at the direct division method. So this is what we have been seeing all along. We directly divide the number by the divisor. So for example, directly we divide 31 by 7 and we say remainder is 3, or 3841 we directly divide by 8 and say remainder is 1, or 7788 we divide by 7 and say remainder is 4. Okay, so this is the approach which we all know how to identify remainders by direct division. But the issues with this method is that it works only for small numbers. Okay, for example, 7788 is a small number and 7 is also a small number. But if you have large numbers such as 3 power 24, which can consist of at least like 8 digits or more, so for example 6 or more digits, easily can consist of 4 digits or more, right? So if you are considering a number which can be very large, for example 3 power 24, dividing it by 7 by the direct division method doesn't make sense, because first we have to calculate such a huge number, which can take a lot of time. So we need to use a different method as compared to the direct division method, called the pattern method. So we will look at the pattern method in the subsequent slides. We will look at the remainder theorem in a separate video, because it requires a separate, it's an advanced topic and it requires a detailed explanation. The pattern method is very simple. It requires you to identify the pattern of the remainders which are left out for each subsequent power of the number. For example, what is the remainder after the division of 3 power 67 by 4? Okay, clearly we cannot do the direct division method here. We're trying to identify the patterns. So remainder of dividing 3 power 1 by 4 is 3. 3 power 2 by 4 is 9 by 4 is 1. 27 by 4 is 3. 81 by 4 is 1. So clearly we are observing a pattern of 3131. Okay. So if it is the remainder, if it is 3 power 1 is 3, 3 power 2 is 1, 3 power 3 is 3, and 3 power 4 is 1. So clearly for every odd number, the remainder is 3, even number, remainder is 1. So 67, 3 power 67, 67 is the odd number. So the remainder will be 3. So just you have to identify the pattern and arrive at the remainder. Next is, what is the remainder after division of 4 power 46 by 7? So this is again similar. We have to identify the pattern, but here the pattern is slightly different. Okay. So we are seeing that the remainder on dividing 4 power 1 by 7 is 4. 4 power 2, which is 16 by 7, is 2. And 4 power 3, which is 64 by 7, is 1. And 4 power 4, which is 256 by 4, is 4. And 4 power 5, which is 1024 by 4, is 2. So clearly here we are not seeing a simple pattern like 3. We are seeing a pattern repeating after every 3 powers. Okay, for every subset, after every 3 power, 4 power 1, 4 power 2, 4 power 3, we are 4 power 1 followed by 4 power 2 followed by 4 power 3. After that, again the pattern is that it is coming to the pattern as 4 power 1. So we need to identify if 46 is going to be coming at which place after every multiple of 3. Okay, so we can write 46 as 3 into 15 plus 1. Okay, so which means that after every 15 sets, so these 3 are considered one set. Similarly, we have 15 such sets, after which the next set, the first number will be 46. So 46 will be over here. Okay, assuming that there are 15 such sets like 4 to 1, 4 to 1, there are 15 such sets, the next number will be 46 over here, and that will be a remainder of 4. Okay, so this is how you need to identify the pattern and identify the sets in each number of numbers in each set, and then arrive at where your number is placed after each set. Okay, now let us look at CAT 2003 question. Okay, this is 4 power 46 by 7. Now let us look at CAT 2003 question, which they asked, what is the remainder when 4 power 96 is divided by 6? Okay, this is actually a CAT 2003 question. The options are 0, 2, 3, 4. So clearly, if you identify the pattern, you can see the remainder is 4 power 1 is 4, 4 power 2 is 4, 4 power 3 is 4, 4 power 4 is also 4. So which means that the remainder is 4 for every possible number divided by 6. So this is a sitter question which you should not miss in the actual CAT. Okay, so the answer is 4. So that's it for this particular video. So as a quick summary, what we have covered is the direct division method and the pattern method. In the next video, we are going to look at the remainder theorem method. So in the meantime, you can take the mock test on reminders in our Android mobile app. And if you have any questions, you can always reach out. Thank you.